And it'll also count like how many references there are, and then it'll say when we get to a point where any objects have a reference count of 0, out the window they go. But now you'll notice that this one didn't increment because it's not descendant from our root. So all those objects can then get marked and let go of. And then the GC compiler, the GC does not, it stops doing what it's doing, so it unfreezes the application can keep going. Now, ideally, when you freeze an application to a garbage collection, it's happening in like a few milliseconds. You have a question?
Here's walking through the syntax tree, or is that tree right there?
Yeah, this is a visual representation of an abstract syntax tree.
I'm wondering how this split disconnected nodes if they're no longer being referenced, going through the tree, and they're no longer attached to the tree, not they are like they're referenced.
Very good question. So let's say, one example that I can think of for this that I have encountered a lot is if you have, say, a running web server. If you have a running web server, you'll spin up, netty threads, which are just basically a single thread that listens for a web server endpoint. And, you may, the JVM, you can either instruct it to spin up a fixed number of netty threads, or you can even get clever and try and program it in a way where it'll expand and contract the number of netty threads that it has running. So you can then spin up more in order to take on more services or less. Each of those netty threads, they're going to have their own attachments. So if you end up at a point where something is just spinning off on its own and doesn't respond to the GC compiler, or GC, why do I keep saying that? To responding to a GC action, then that may get cut off. Also, if you then say instantiate a global object. Like, again, let's go back to the website counter as an example. That's a global object that is not directly created within the scope of a function or a class. It'll be its own class. So you may, there may be other such elements that are spun up out there outside all of the known code objects that allow things to get collapsed. So
does it walk the stack and look at the pointers and see which ones are connected to the root? Okay.
Yeah, more or less, yeah. All right, because what's happening is all of these marks are going into the code object references on the heap.
Right.
And so if you have heap objects that have no references on them, out they go. All right, cool. So then later on, more code objects can be spun up and also dereferenced as well. Like when your root process says, I don't need that netty thread anymore, it'll cut it off, but it may still be lingering in memory unless you actively do a deallocate or free or something like that. Or you just let the garbage collector take care of it. So in a way, having a garbage collector allows you to write messy code. In a way. Although some of the messiest code I've ever seen was Python code written by C++ developers, but I digress. All right, cool. So that's what's called a mark and sweep process. And you'll hear also the term concurrent mark and sweep, because mark and sweep can be done single-threaded or multi-threaded. If you have a process that's taking up all of the cores on your processor that it has available to it and spinning up a bunch of threads, you can issue it to say all of the working threads go through a GC, and it will do it. It's, technically, I'm not going to say that because I don't know. Never mind. So what happens then is when you go through and you sweep out objects that get kept around are what are called tenured, and then they move out of, all new objects are created in what's called Eden or a young gen heap space, and then once they get swept through and tenured, then they get moved down to an old gen space. Now again, these are just stack references. It's not like the JVM is deleting this code object and copying it from here to there. It's just changing in reference. So these older gen objects, they tend to be more stable objects. Again, if you have a static fixed number of netty threads, as an example, the root of those netty threads could be move to old gen pretty quickly, so that way they don't get touched again. But the sub-processes that they start up in order to do something like render an API call, or authenticate TLS, or load a document from somewhere else, those things can all happen in young gen and then be evaporated as they finish off. Okay?
What does promotion mean?
Promotion.
Yeah.
Well, you're promoting something from, well, I think I actually get to that in another slide. Generational buckets, exactly. So, in the JVM, you basically have two major memory buckets. You have the young gen and the old gen. Even in the young gen, you kind of mark things into two spaces. So, when that sweep goes through, I'm sorry?
Survivor.
Yeah, it's in the JVM white paper. I did not make this up. So, new objects get created in the heap, and that virtual space in the heap is called Eden. So that's where everything is new. And then when that first CMS happens, and everything gets marked, everything either gets marked as, to be swept away and deleted to free up memory, or it's a survivor. And then at the end of that, survivor objects get tenured into old gen. Now, generally speaking, young gen sweeps are fast because as your process runs, it's creating objects, it's creating allocations, and it's throwing shit all over the place. And the more solid, stable things that are at the root of everything, the compiler then knows it doesn't have to touch them as often because it already did. And so then those get moved to old gen, and then they can sit there for a longer time. Does that answer it as well? Am I making sense though?
So this is predominantly an optimization, right? Like things that have been around will tend to stay around, so we don't have to try to garbage collect them as frequently?
Correct. So you'll see more rapid events happening on your young gen, and then if the young gen doesn't free up enough memory, then we start sweeping old gen. And when you start sweeping old gen, then your Java process actually slows down, and your end users are pissed off at you because the page won't load. Cool. All right. So, yeah.
So the idea is that garbage collection is happening sort of all the time. Or maybe not all the time, but it's happening frequently. It's not just waiting until there's no memory left.
Yeah, it happens kind of as it needs to.
Yeah.
So it happens as you're running out of memory, as opposed to when you actually run out of memory. And that's because building up the action of a garbage collection consumes a tiny amount of memory.
So it is happening late in the day. Because I was sort of imagining it happening like periodically before we even got close to filling up.
Yeah.
But it's not.
It's not always the case. And so I plan on giving a second half of this talk at a later date, where I'll talk then about real world. When this is happening, what does it look like from an observability standpoint, from a customer standpoint, things like that. And then how do I respond to it, And that's a whole other talk altogether, which I'll put together for the next round. All right. So, how do I deal with it? Well, the first, of course, important thing is to do your monitoring, which again, like I just said, is going to be a whole other talk entirely. So, the amount of memory that you use in your JVM, the amount of allocated heap, and the frequency of your GC and the time spent in GC, those are all metrics that you can monitor and make decisions about what to do when you see those numbers start happening. If you see really frequent amounts of CMS events, or you see a lot of time spent in CMS, you might want to cross-check that against what is your slowest response time look like to your customers and make a decision accordingly. I'm of the mind of, if my customers don't notice that we're slow, then I really don't care. Because this is a well-built process that has been managing JVM processes on services you and I use for decades. Yeah? A version of this happens on Android phones with the Dalvik interpreter, which is really just, you know, depending on what the lawyers say, a replication of what the JVM does. Anyway, so the other thing you can do is consider how you allocate your memory. So you can make decisions early on about how much memory is allocated to Eden and to Old Gen. And that way you can then, you can kind of tune your interpretation, tune your garbage collection to happen effectively in a way that will allow your process to run well. You know, so if you know that you have something that's doing a lot of short-lived processes, you might want to give that a few more Old Gen, give a bit more space to your Old Gen. That way things work better. You know, if you have a lot of pre-caching that happens, you know, this is something that you might see with like CDN type of activity, because if you're pre-caching your responses that are going out to your API, things like that. Yes?
Just out of curiosity, when you have the old gen, new gen, are those like functionally two different heaps, like they're literally different memory addresses, or you're just kind of saying you have this much for this and this much for this, figure it out?
It's that. It's the latter. I think. You know what? I'm not 100% sure. Don't quote me on that. Does anybody else know the answer to that?
Functionally, it's probably identical. It's just
yeah, I think ultimately it's really just references to the same objects, and the references get moved around. And that could be like what they started doing with the Graal compiler, which I'll talk very briefly about later. Right. Oh, actually, no, I'm on that slide. So a few years ago, the folks at Oracle, who basically own the Java language and compiler and everything, you know, hence lawsuits, they wrote the Graal virtual machine, which the original JVM was written in C++, and they rewrote the JVM in Java, using Java to be the JVM written entirely in Java, so that way, you know, it's kind of like they bootstrapped their own virtual machine. And they put a lot of niceties in there, including dynamic resizing of your heap. You know, like when you start up a JVM, you have to say, here's my heap overall, but the dynamicness happens between sizing of your old gen and new gen. So that could be something that they're doing, is automatic re-referencing within the heap. I do not know enough about that. I will read more, and maybe on the next talk I can add more on it. Okay, cool. Now let's talk about memory leaks. Who knows what a memory leak is? I know some of you. You want to tell us what a memory leak is?
A reference object that is never properly dereferenced, so that it always has a dangling reference from the root node, and it can never be properly deleted. Exactly.
Did everybody get that?
Yep.
All right. So yeah, when you're, well, you said this. So, you know, examples of this may be like you create a whole bunch of code objects, but your function doesn't cleanly exit, so all those code objects stay referenced to that. So all they do is they just hang out there, and then every time there's a generational sweep, those objects are still there and they never get purged out. They then get tenured, and then your tenured space blows up. So, and your code objects then look something like this, and then you say, I no longer need those, but I haven't dereferenced these. One place where this is, it's gotten better over time, but about like 4 or 5 years ago, there was a huge problem in included libraries for Go, because the pipes in Go, which is how you do inter-process interoperability, didn't make it very intuitive about how to close them. So you would have objects that would open a pipe, share objects between processes, and then that would just sit there. Now, Golang has its own compiler that it has its own interpreter that it installs when it compiles, and it does its own memory management. So but it wasn't catching those things. So, yeah, what are you going to do? All right, So one way that you can try and help manage this is keep all of your functions discrete and small. Not only does it make it easier to reason about and manage your code in general, but if you have small discrete functions, then it becomes easier to say, okay, where is this problem happening? And then you can like narrow down and say, okay, cool, I've used this code object here, now I can release it, things like that. Similarly too, you can do cool things like use compilers, profilers. God, I keep saying that. You can use profilers. Who knows what a profiler is? All right, you want to tell us what a profiler is?
Profiler allows you to put a trace inside your code so you can see how many times it executed and where the references are.
Very good. Now, one really cool visual representation is Brendan Gregg's flame graph. You've seen this. Yeah. This is really cool. And I've used this to debug many a memory leak. So the whole idea behind this is that you're building up an inheritance tree. Here's your root node, and then on top of that, other code objects get built up. And the width refers to, it's somewhat visualization of how much memory is being consumed by that particular layer in the stack. So if you see a real, I'll use this, pick on this one as an example, it's wider than the next stack up. So this element has some allocated memory that is not being used further up the stack. So if you look for trees where everything is like skewed narrow up tall and you've got a few really wide objects somewhere in the middle, then you've got existence of a memory leak there, potentially. It's kind of like, a profiler won't give you all the answers, but it'll give you hints. And ultimately it's up to us humans to figure out what the hell we did with the code that us humans wrote, right? Cool. All right, so a few takeaways. Garbage collection is memory management, plain and simple. Unused blocks of memory are freed up through analysis. Those analyzed memory objects, they either get promoted or tenured or freed up through the mark and sweep process. Things that don't get freed up in the mark and sweep process, if they grow unchecked and really don't have any use, then that's called a memory leak. If you want to read more on flame graphs, Brendan Gregg, who is a very old wizard site reliability engineer at Netflix, formerly at Twitter, wrote this whole thing about flame graphs. It's embedded into a lot of common Java frameworks out there because it's useful as hell. And they make cool working graphs too, but it's really useful when you have to actually debug stuff. So that's all I have to say about that.
Yeah, his super performance book is awesome.
Oh yeah.
It's updated now.
Yeah. All right, any more questions?
All right, so, once again, big hand for Brian. We'll give you another 5 minutes or so to socialize for a little bit while Laurie gets ready for her talk. Sorry.
I like going.
You work on Netty
So going profiler.
No, I did not.
You didn't.
No.
So you worked with Nathan.
With who?
Nathan Hubbard.
Oh, yeah.
And it'll tell you
yeah, you're Nathan's friend.
Yeah.
I forgot your name though.
Whit.
Nice to meet you. Yeah. All right, cool. I'm gonna get her moving, and then we should talk a lot. Yeah.
I've had to fix. You were not working on this before.
I am, yeah.
That was nice to have.
Always.
Yeah, we did great.
All right, cool. I'm getting Laurie set up. Tyler in the hat right there. You should talk to him.
I'm done.
Possible speaker. Okay. I am watching Discord crash on itself, trying to get your slides up in here.
Discord's the node, and how would you?
Let's see, this would be my work laptop, this would be my work email, this would be Brian with an I, dot Fletcher, 1B.
Modern physical link is on that front, but I like writing. That is the previous one. It's a fun one to try out.
Brian dot Weber at Coralogix, CORALOGIX.com.
All language, special words. They don't do things, they're very explicit, they're very opinionated, it's very heavy language, so they don't do things like, generic. They're starting to force, people are starting to force that.
That's right.
So people are trying to do generic, but they didn't, when they started, they didn't do generic at all. So, and then all that, which is so nice. Oh my God. So nice.
Yeah, I can do it for you if you want.
They have a format.
Okay, use the arrow keys with the space bar just to
And give a tool as part of the language that I format them for you. Yeah.
There it is.
I have like a little microcontroller where I'm like, that sounds.
Well, this check out my PR.
Yeah. What did I do?
Yeah.
I was like, okay. Yeah.
Okay.
Yeah, go format site. I like it, I like it. And I don't even think about it anymore, it's not a Right.
So, there we go.
Yeah.
No.
So yeah, if you ever run into a parallel project,
So
just want to try out, even if you don't, especially if it's one on your own, but I think parallel is so much better. They all built on all the entire chair, but product natural built in, but then it's made so that you don't have to get you don't have, like, they can give you a primitive that is so it just opens up for you. And that's why libraries for use the meetup. No one overtakes it.
There we go. Very cool. So again, you can do like left and right arrows, advance, go back, or advance only.
Make your life favorable that way.
Alright, cool. Sure. Need anything else, you know where I am.
Yeah.
I'll leave that there for you. Isn't that what, I think that's what I did. Alright, cool. If you have any other questions or concerns or issues, just give a shout. Alright, cool.
I like that, everything like a library on object. I like that about it, pretty short. Because so for my team, we have a lot of different projects.
Alright, everyone. Make it a little louder. Hi, everyone. All right. I guess I can't get it back. All right, so Laurie's going to be giving a talk about ports, protocols, and patches, locking down the security of your integration. Laurie is an app administrator at PacificSource, not university, healthcare.
Health insurance.
I get the two mixed up because my sister goes to Pacific University, so that's where that came from. Anyway, thank you, Laurie.
We have a fun whirlwind of things to get through. We're just going to kind of talk about integration, so getting data from point A to point B and how to not fuck up in the middle. Because that's kind of how most of the breach is happening, unless, of course, you're the person who clicks on the phishing email, and that's a conversation we won't regular.
You're still moving data from point A to point B.
You're moving a lot of data, not what you expect. Or you're moving it to somewhere where you didn't expect it to go, as may be the case. Anyhow, as mentioned, I'm an app admin at PacificSource. So one of the things that I administrate is GlobalScape, which is an SFTP server, and I also administrate a couple of web portals. So everything to do with file transfers, I kind of, talk about it as it's air traffic control, but for files. So I'm not a developer. I don't do the file processing, but I help all of the developers, we have about 80 developers at PacificSource, to get to their files. And so we have accounts with give a really low ballpark of about 600 counts. It's probably a lot more than that, that I work with. And so every file that comes in or out it goes through one of my applications for the most part. And so I get to see all of the data loading processes and all of the breaking points. And I get to see kind of the window in to all the file loading. So while I'm not a developer, I do a whole lot of PowerShell scripting and a lot of low-code, no-code kind of automations and kind of help everything talk to each other. It's kind of an interesting position. Also ServiceNow administrator, so kind of, on the side. So IT ticketing management system, if you're familiar with it. And then PagerDuty, of course, and then we have probably 5 or 6 core applications, but those are the main ones, ServiceNow and anyhow. So our topic for this. So we're going to kind of cover file transfer, mail protocol in its role in integration, and a little bit of web transport, HTTP, HTTPS, everything the web is built on. And then cover a little bit of API security and talk a little bit about the Move It ransomware attack and how your data has definitely been sold on the dark web this year, if you look north. Probably multiple times, in fact, from multiple different agencies that have been hacked. Anyhow, so to just get this right out of the way, because I imagine there are people who are curious, what is the most secure protocol, and then rank them. So I went ahead and ranked them just pretty quickly out of the way. So SFTP, with a major asterisk, if configured correctly, is the most secure. Can you configure SFTP very poorly? Yes, you can hack it with a cell phone. It doesn't take very long, depending on the encryption ciphers and depending on how you configure it. It can be the most secure, or it can be down here. So it just kind of depends, and it's kind of on you to go figure it out. If you own the server, you own the breach, you own the security on it, you have to go read and become the expert. If you have a cybersecurity analyst or team to consult, you should do that proactively. If you're the end user, if you're, interacting, you have an account on someone's server that you send files back and forth from, if you're using password only, you can do things like ask, hey, can we use an SSH key? Can we do two-factor? Can we use both an SSH key and the password? So those are the things that make it the most secure. Below that, HTTPS, the standard, web transport. Pretty much everything operates on HTTPS on the internet. Most APIs go over HTTPS. If you're working in HTTP, you should ask yourself why you're not in HTTPS. Implement that together. I just kind of put the standard ports. You can customize these ports. These are the default ports. And so FTPS, it has a few, but also with FTP, because there's a difference between data and control. We're not here to get into the specifics of it, but basically multiple ports open is bad. You should have fewer holes into your firewall. So, one port is ideal. FTPS is still better than some of these others. SMTP, you could probably interchange these depending on, the configuration, but this depends on configuration for all of these as the ultimate ranking. So this is my opinion of all of the different ones. Anyhow, let's just get that out of the way. This is when they were all rolled out. 1995, I put both on these because mid-90s or so for both of these. FTPS extends FTP. This is FTP over TLS. Secure Shell is uniquely different than, which is why it was developed about the same time, because this was coming from just a different pipeline, different development, if you will. FTP, it's been around for a while. I wasn't even alive when FTP and SMTP were rolled out, so that's how long some of these have been around. World Wide Web pretty much built on HTTP, and then, we made it a little bit more secure a couple years later. So let's just kind of give you a little bit of a history of what we're talking about and how long it's been around for. Going right into file transfer stuff. So FTP, who has not used something like FileZilla on an FTP? Who's not familiar with FTP? FTP type stuff. Who's never used it? what I thought. So, I'm going to just kind of do a very brief overview of this, because I kind of expected you guys to be relatively familiar with this. So we have, FTP unencrypted. We have an encrypted version, which is just FTP plus add TLS, so, add a cert. And then we have secure shell, which is a different protocol and is more secure than these, but you also lose a little bit of speed, which is why we still have FTP servers, although it is not secured. When might you want to use it? Well, if you want everyone to be able to have your files, not really a problem. If you say this is publicly available, perfectly acceptable protocol. Do know that it's also easy to hack in and do things like, let's just say, encrypt all of the files that are on that server. You should just anticipate that, if you do manage a server that uses FTP that's not encrypted, you should just assume that it could become, your entire server could become encrypted, and you might have to delete it and replace it. And, start new, so that's our bad. Yes, this does happen. This still happens pretty regularly.
So why hasn't it happened to archive.org then?
Archive.org.
The big massive website full of all kinds of archive stuff?
Oh, I don't know.
Archive.org?
I don't know what their security looks like. You would have to get pretty intimate with what their configuration is.
Okay.
And why, right? So, does anyone want it? Are they going to pay $1 million to get that data back?
I don't know. The archive.org, I just know, is full of all kinds of different files and ancient, everything.
Yeah,
Well,
it kind of depends on who wants it
operating system.
and who's willing. So ransomware, right? That's
Yeah.
what I'm referring to. Is someone comes in and encrypts everything and says, "Pay me money and I'll unlock it for you. And if you don't pay me money, I'm going to go sell it to the dark web. And even if you do pay your ransomware to get them to unlock it, there's no guarantee that they're not going to sell it as well."
Yep.
So payouts are happening a little bit less often for ransomware. We'll touch on ransomware a little bit more towards the end. We're going to kind of cover the Move It attack, which was ransomware. Anyhow, so just kind of a little overview of some benefits. This is one of my particular transfers. I had a file. I think it was actually 271 gigabytes. It was about half terabyte, and it took about 120 hours. So one of the beautiful things about SFTP is it just keeps going. So it can get interrupted, and if something happens, you have some interruption because, the server goes offline for maintenance or something, when it comes back on, it just continues. There's no interruption. So it's ideal for large file transfers, anything that's automated, because it just picks up where it left off. If something fails, it just tries again, in 5 minutes, 10 minutes, whatever you set it at. So there's some benefits, but these are all for file transfers, right? Let's see, large FTP. It's not perfect. Part of this was to kind of just introduce what is two-factor on SFTP. And so we have this, I probably could have pulled this up more. We have a little person, and they have a username and password. That is one factor. They have an SSH key, which has a passphrase to the key. That is one factor. Put them together, have two-factor, which, is part of multi-factor. You can also use an additional, depending on the server, you can require IP whitelisting, which would then be 3 factors. But point is, username and password, that is one. SSH key, that is a second factor. Put them together, now you've got 2. So anyway, your person, you authenticate, you have to use an SFTP client application like most of you should be familiar with. It might be something like FileZilla, WinMCP. There's a lot of automated programs. I use Coralogix for our server, PacificSource. You might also be using something like Visual Studio. You might have a scripted solution that uses SFTP, and if you are doing that, you should really make sure that your encryption ciphers are selected appropriately, because you may have an SFTP connection with the worst ciphers that there are, if you haven't configured that, and that's something that you can go look at your registry if you're running it off of, a specific server or off of like a virtual machine, depending on where you're scripting that from, wherever it lives, there are configurable options. That's where you gotta get down to the registry if it's not like a managed solution. So like if you have, a server, an application that manages it for you, you can go configure it in an application. If you don't have an application like that, that's where you need to go get cozy with the registry and go look at how to restrict ciphers, which we'll get into in a little bit. But this is just a little thing that I came up with at work of how, if they use an SFTP client application, we have an SFTP tunnel, which is encrypted, and, if the connection is successful, then the person is able to interact with the file, with the folders that are on their account on the server. They upload the file, and we have an automation, and it goes to one of our employees for, applications that actually processes the file. If the connection does not succeed, they get an error message, and then I work with them to figure out the problem. Anyway, there's different failure points on here, which is basically wrong password. Most of the time, it is either they don't enter the correct password or they don't use, two-factor. Because at PacificSource, I require two-factor authentication for an account on our server, which is kind of like the gold standard. I think there's out of all the agencies that I've talked to, I think it's like 0.01% of agencies are using two-factor on SFTP. It's becoming the next thing, but it's still kind of early. Anyhow, a little bit of cryptography. So about those ciphers that you need to select and make sure they're good ones. So my rule of thumb, because I am not a cybersecurity analyst, but I have a team of cybersecurity analysts that I pick their brains, and I'm going to have to actually go select all of these, and so I just ask questions. These are actually screenshots. This is from my server. This is my dev server, and the bigger the number, the better. So so for instance, here we have 512 after all of this other stuff. That's good. Here we have 96. That's not so good. So kind of like the 256. That's a good number. 128, not so good. No numbers. That's really bad. That's the Laurie rule of thumb with, I don't know, I'm not the expert of these, but just pick the big numbers and you're probably doing pretty good. Pick the biggest number you have and then drop it down 1 or 2, and that's where you should have your cutoff point. So like here we go up to 521. I'm like, that's a pretty good number. 384, that also seems like a pretty big number. And then 256, and then let's just cut it off. Anything smaller than 256, we're just going to say no, we don't allow that. And that's a pretty good rule of thumb. So really you should be doing 256 and above is ideal. For compatibility, you might need to enable some 128. So for instance, this AES 128, the CTR and CBC, there are some applications that don't go more secure, more modern than 128, the AES for ciphers. And so I would suggest if you're looking at configuration like this, wherever that may be, go with the most restrictive, the most secure, and if it becomes a problem, then back it off a little bit and then, enable the last wave and try to also have a conversation with who can't use this and why. I have a lot of those conversations of like, hey, you should update your application because you're going to get attacked. That's a very common conversation, probably 10 times a week that I have with our partners. Anyhow, big numbers, good. But if you ever
a T-shirt for that?
Yes, if you ever see this list, you should pay a little attention to it and disable all of these old ones and just do a quick Google search and you'll be able to find like what should my cutoff point be. And so that's SSH, so that's secure shell. This is for FTP. I don't allow this. I just figured I would just throw it on here as what types of things you might need to configure if you're managing FTP or FTPS. Again, I don't allow those ports, they're not open on my servers, but there's more configuration involved with FTPS. If you happen to have a server with an open FTPS port, or ports rather, 572, you should go be a little bit of an expert on it, because it is easy to have big problems with that. Kind of like FTP. FTPS may not be secure unless you really configure it securely. Very brief overview of mail protocols. So SMTP, not encrypted, but you throw TLS on it, and now it's encrypted. So again, it requires configuration, those ciphers that we just looked at for secure shell and SMTP. SMTP has similar stuff. It's really TLS, but it's specific to mail servers, and I am not a system administrator of mail, so if you happen to be one of those system administrators for mail servers, go be an expert at the encryption for what it is you are managing, because it is only as secure as you make it. But the point of talking about SMTP is we do use it for integrations for getting data from point A to point B. So there's, of course, the obvious email. How I see it in a lot of integrations is we use it as a trigger. So you might have something, some application that has a process, processing something. Garbage collection, that's probably a terrible example, but let's just say your garbage collection function or whatever is done, and it says, I'm done, trash is taken out, and you want to do something when that process is done. And let's just say you have, ServiceNow, and you want to put in some kind of a ticket to automate something else. You can send an email to ServiceNow. Many applications offer this kind of, low-code, no-code integration. It can accept an email as a trigger. And then you have some kind of logic that hosts in the application that says, when I get an email from Mr. Garbage Man saying, I'm done, do this other thing. And so it can receive that email and do whatever thing you want to do. It could be something like, processing a batch, for batch process files, obviously that's what I work with, so that's what I'm familiar with, but you can use email as a trigger to send data. And so you want to, if you're going to do that, if it's SMTP, no encryption, totally fine. Just make sure that there's nothing sensitive or secure in that email. And this can go within your own organization, like all safely within your own firewall, or it can go out to, business to business or wherever, the cloud, whatever it is you may be working with. Email is extremely useful because you don't have to deal with authentication with an API. It's just a simple message. And you handle the logic on the receiving end. I receive the thing, I do something. That's where the logic is. The API, the logic is typically like if you're sending the information, the logic is on your end. So it just kind of depends what you're working with, but it's quite useful for that. Here you go, I have a breach example. I can remember back to 2016, the whole email situation. I think Ms. Clinton was like the poster child of some email issues. That was phishing. Everyone knows email prone to phishing. That's like the number one, attack, which it's not specifically an attack over the protocol itself. It's an attack to the people, which is your weak link typically. Because you can't really automate people. We all do stupid things. We all click on the wrong thing sometimes. Anyway, that's just a little thing about email. And then web transport, again, why did that come there? Let's skip over that, just go to TLS. Okay, that was a bad source. TLS, same kind of thing as what we were looking at with secure shell. When you start seeing these encryption processes, all these different numbers, all these like, oh, what is this? This is all cryptography, different encryption. Do a quick Google search, because whatever it is you have options for, there's good options and there's bad options. And so, for instance, TLS. So TLS, SSL, you can kind of see over here, SSL v3. And then we get more recent, TLS version 1, 1.1, 1.2, 1.3. you didn't know, TLS and SSL, it refers to the same thing, it's just a matter of which era we're talking about. So, SSL is a little bit older. Really, you should be cutting it off at about TLS 1.2. If you have to, enable TLS 1.1, you should have a reason. And again, you should be talking to why. Is it some application that needs to be updated that still relies on TLS 1.1? Is it, someone's browser? Do you have like 2 customers that haven't updated their phones in 7 years or something? Like, maybe you don't need to enable this for those 2 people, So just kind of ask yourself why if you're enabling older protocols. So again, this is just a screenshot from what I have set on my dev server, and so from all of these different settings, so it's like we have encryption with MAC, key exchange, authentication, and our cipher suite. Here are my choices for each of them. My resulting cipher list, I have 9 ciphers available. I work with hundreds of accounts. I have yet to have any problems with any of these 9 ciphers not being an option. So for, category here, you have MAC, encryption, key exchange. You just need to have one compatible option, for each connection kind of thing. But anyway, the point is, if you see this list, do a little Googling, do some disabling. If you see all of them enabled, that's bad. You should probably go do some purging. And that's probably going to be at the registry. Yes?
Can I ask specifically about MD5 there? I was under the impression that was considered fairly weak nowadays. Is that, do you consider
There is
that?
a specific reason why that's
Is
one
that
of them.
a compatibility thing?
So that is, I had a very specific partner that relied on this specifically and did not have one of these 2 available, and we had to make the decision, do we allow that or do we not? And business decision was enable it, give them a year, and then we'll cut them off.
So when you have to make a compromise like that, are you usually like,
Documented.
this is your sandbox, this is like the liability that you are
That
taking for
is,
this?
you are going to have a signature agreement with them, as in, we would like you to stop using this within X amount of time, and you have them sign that paper. Highly recommended if that's what you encounter. So, yes, there is a specific reason for that one. Good catch.
Yay for documentation.
Exactly. Oh, God, we just got done with our high-tech stuff. This is kind of the left slide, but just in action. I'm not going to get into it too much, but I kind of like this little visual in terms of what are these things, how do they work together. Point is, all of the things that we set our ciphers for, so like, here's that 256, that's a decent number, right? Cha-Cha 20, this is probably a little bit older. But part of this is just all of these encryption filters, they work together to build you a secure connection. So that way, when you go from point A to point B, you are going through an encrypted tunnel. And everything that you send through that tunnel is protected from things like man-in-the-middle attacks. It's not just a free-for-all of like, hey, this is open data. It's at least the connection itself is encrypted. The files themselves are only encrypted if you encrypt them or if you hash them. So you can use PGP encryption. That's for the file itself, or if you hash it. But this is all just to do with the connection itself. So this is authentication and encryption of the connection to give you a safe channel to pass through all of the dark web, basically, and everything that's trying to get into your stuff.
Do you have any situations where you're using mutual TLS for file transfer?
I don't, but you might.
I wouldn't wish that upon you, but.
I would say I need someone pretty high up in my organization to write a justification as to why.
Yeah, that's what I can point.
All right, so we looked at TLS just a little bit, and so most APIs use HTTP or HTTPS. There are some that use other, there are some APIs that can go out over SMTP and over mail or the TCP/IP, depending on what you're working with, and then there's a few others. But the overwhelming majority of APIs, and there are many, many types of APIs, they work with many data types. You know, you have some that are just internal only, you have some that go business to business. For anything that you can think of, there's probably an API for it. You know, if you use a phone, that's how you get data. It's all going over all these different APIs. I mean, there's a lot of web developers and web-interested people here. You probably know a lot more about this than I do. I just kind of threw, you know, REST APIs are kind of gaining in popularity, I think. They're very popular, and they're very common. There are other ones, you know, COM API. I've had to work with the COM API with my application. I do not love it. They have a new REST API. It's much less documented, but better overall. Anyhow, whatever type of API you're using, it's probably going over HTTP or HTTPS. If you are not using HTTPS, you should ask yourself why. And if you own the data, you should probably require SSL. If you don't own the data, you should probably try to figure out, can I get this over HTTPS? Do I have to use HTTP? Why? Why can't I use an encrypted connection? Even if it's perfectly accessible data to the public, for instance, you might want to not let everyone know the type of data that you're interested in, because again, anything that's unencrypted, someone can come in and say, encrypt all of your stuff, and now you have ransomware to deal with. But that's the back of the matter. Anyhow, updates. Updates are probably the biggest way that you can avoid problems, other than just training your people not to click on phishing emails. But keeping your stuff up to date. If you're familiar with like terminologies like CVE dash, you know, some number, that's a vulnerability. CISA has, you know, a ton of information about that might pertain to your applications. They actively scan for known vulnerabilities, and you should probably be using some kind of security monitoring for your own application. If you're having to like go look at this list manually, that's a problem. You should have active security monitoring on whatever systems you're using. So this was just kind of like a brief thing about authentication. You know, we talked about encryption, authentication for APIs. So do you have encryption for HTTP versus HTTPS? No encryption on HTTP, but then there's the authentication. So you should be using, you know, API keys. For most APIs, you may need to use something like username and password. Try to get that into a key. You shouldn't be using username and password when you can avoid it. And if you must use username and password, you should probably store that somewhere very securely and then turn that into a key, and that's what you should be sending over on your script. Most API keys, you know, they last for about 20 minutes. If you set the timer, you know, if you own it, you should be setting that to, you know, in 20 minutes, probably a good max before you have to re-authenticate. You know, someone else is accessing your data. There's this fun thing of Azure Key Vaults, and I believe Amazon Web Services has a similar thing where you can go store some credentials, like let's say username and password, and you can have a script, and your key vault and your script can mutually choose not to pay, they choose to just accept the risk that all this data is getting exposed, because again, if you pay, there's no guarantee they're not gonna expose it anyway. So, yeah, backups are huge with that. Move it, that's how that happened. Overall, it was a SQL injection attack using their API, not secured, not sufficient data validation, is really how that came about. In a nutshell. Further reading if you wanted. Lingering questions?
Till 8:30. Okay. All right, well, let's hear it again for Laurie. We will be present until 8:30, so feel free to have more food, socialize, drinks, whatever. We're here till 8:30, and then we'll start wrapping up at that point.
Well, there are two kinds of developers that see that block. There are two kinds of developers that see that block that.
She said you were from DevOps.